Hello, in this lecture we'll find out the value of x. In the drawing we have a quarter circle, AFE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment DE is equal to 12 units in its length. This is angle GDC is equal to theta. This is angle CDE, it is also equal to theta. Repeat again that our mission is to find out the length of this line segment GD that is equal to x. Our mission is to find out the value of x. Okay, so first of all, we'll start with the first method, and we know that all the angles inside this square ABCD are right angles, so this angle inside square ABCD is a right angle, equals to 90 degrees in its side. This angle is also a right angle, is equals to 90 degrees. This is a right angle, is equal to 90 degrees. And finally, this is also a right angle, equal to 90 degrees in its size. So, what is the size of this angle? Angle ADE. This is angle ADE. Although it is very easy to see that angle ADE equals to the big angle, angle CDA, that is 90 degrees, minus angle theta. Again, 90 degrees minus theta will be equal to this angle, angle ADE. So this angle equals to 90 degrees minus theta in its size. In the next step, we'll do a construction, that is to say we'll extend line segment GD and this line segment EA by a straight line until they touch each other. And we'll define the touching point of the extended line segment EG and the extended line segment EA, this point as H. In the next step, we will extend side CD of square ABCD by a straight line. And define this point as F. By extended line segment DC and by extended side CD, we created here two vertex angles. Those two angles, that is to say angle GDC and this angle ADF, they are both defined as vertex angles. And you know that vertex angles are equal to each other. So this vertex angle equals to theta, therefore the other vertex angle, that is to say vertex angle FDA, must be also equal to theta because they are equal to each other. So we extended the straight line CD by straight line, the result is CF. When we extend the straight line by straight line, the result must be a straight line. So CF is a straight line. If you focus on the lower side of the straight line CF at point D here, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CF at point D here? This we have those two angles, so this angle equals to 90 degrees, and we have this missing angle. So in total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the lower side of the third line CF at point D to 180 degrees, this angle must be equal to 90 degrees in its size. Therefore, angle HDA, this is angle HDA, must be equal to the big angle, that is angle FDA, is equal to 90 degrees minus angle theta. Again, 90 degrees minus theta must be equal to this angle, angle HDA. So angle HDA equals to 90 degrees minus theta in its size. So we extended side BA or side EA by straight line, and the result, when we extended straight line by straight line, the result edge A, EH, the result is EH, it must be also a straight line. So EH is a straight line. If we focus on the upper side of the straight line, EH at point A, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line, the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of EH at point A? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle, this actually angle DAH, must be equal to 90 degrees in its size. In order to complete the sum of the angles in the upper side of EH at point A to 180 degrees, this missing angle must be equal to 90 degrees in its size. So, in the next step, we prove that those two right triangles can go into each other. That is to say, we prove that the right triangle HDA is congruent to this right triangle, triangle ADE. So I write it down. We prove that the right triangle HDA is congruent to the right triangle ADE. So why those two right triangles can go into each other? First of all, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. This is angle HDA in the right triangle HDA. And it is equal to this angle, that is actually angle ADE in the right triangle ADE. I repeat again. Angle HDA in the right triangle HDA equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side DA. Side DA is the current side that belongs to both triangles. Therefore, we can write down that side DA equals to itself as a current side that belongs to both triangles. Repeat again. Side DA equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. This is angle HAD in the right triangle, HDA. And it is equal to this angle, that is actually angle ADE. This is actually angle EAD. This angle EAD in the right triangle ADE. Repeat again. Angle HAD in the right triangle HDA equals to angle EAD in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So we actually proved that the right triangle HDA is congruent. This is the sign of congruent to the right triangle ADE according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove the two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles in the side that included between the two angles in a second triangle, then actually proved that the two triangles can run to each other according to angle side angle rule. And we actually proved that those two angles, the side that included between those two angles, that is actually side DA, this side DA in triangle ADE are correspondingly equal to those two angles in the side that included between those two angles, that is the same side side DA in the right triangle ADH. Therefore we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side DE in the right triangle ADE is equal to side AD or to side DH in the right triangle ADH. According to the rule that corresponding sides in the right triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides must be also equal to each other. Repeat again. Found out that DE equals to DH, but according to what is given as the equation, DE equals to 12. So you can write here that DE equals to 12. And from this equation, 12 equals to DE equals to DH, we derive that DH is also equals to 12 units in its length. So this is side DH, this is equal to 12 units in its length. Likewise, according to the same rule that the corresponding sides in congruent triangles are equal to each other, we conclude from the fact that those two triangles can go into each other, that side AE in the right triangle ADE is equal to side AH in the right triangle ADH. So AE equals to AH. Repeat again. We conclude that AE equals to AH. AE equals to AH. According to the same rule. What is the definition of side AE? is always to see that side AE or AE is the radius of this quarter circle that will define the radius of this quarter circle as R, therefore AE equals to R according to our definition. AE is the radius of the quarter circle that is equal to R according to our definition. So here AE equals to R, it is the radius of the quarter circle, and from this equation R equals to AE equals to AH, we derive that AH is also equals to R. So here, this is side AH that is equal to R. In the next step, we'll join points G and E together by a straight line. By joining points G and E, we created triangle HGE. This is triangle HGE. So in the next step, we join points G and A together by a straight line. Those 2 points. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, GA is the radius of this quarter circle, that is equal to R according to our definition. And point A in relation to triangle HGE, point A is the circumcenter of triangle HGE. So I write it down. Point A is the circumcenter of triangle HGE. That is to say, the distance of point A from the 3 vertices of triangle HGE that are H, G, and E are equal. For example, the distance of point A from the vertex edge of triangle HGE is R. Likewise, the distance of point A from the vertex G of triangle HGE is also R, because AG equals to R. And finally, the distance of point A from the vertex E of triangle HGE is also R. Okay, the distance of the 3 vertices from point A is equals to R. In addition, because of the fact that point A is the circumcenter of triangle HGE, point A is the center of the circle that blocks triangle HGE. Repeat again, point A is also the center of the circle that blocks triangle HGE. And we know that any circle that blocks triangle HGE must pass through its three vertices that are H, G, and E. Repeat again, any circle that blocks this triangle HGE must pass through its three vertices that are H, G, and E. So it must pass through point E. So what is the radius of the circle that blocks triangle HGE? The center of the circle that blocks triangle HGE is here at point A. The circle that blocks triangle HGE must pass through point E. And therefore, the radius of the circle will be equal to AE, because the center is at point A and it must pass at point E. Point E is the point on the circle itself. This is exactly the definition of a radius. Therefore, AE is the radius of the circle that blocks triangle HGE. But AE, we already found out that A equals to R. So in conclusion, we can say that the center of the circle that blocks triangle HGE is located here at point A. Its radius is R, and it must pass through the three vertices of triangle HGE that are H, G, and E. This is from one side, but from the other side, if we complete this quarter circle to a circle, we will get a circle that its radius is R, because the radius of the quarter circle is also R. Therefore, the radius of the circle that will be created by completing this quarter circle to a circle must be also equal to R. And the center of the circle must be here at point A. So we have two circles. One circle that blocks triangle HGE, and the other circle is the circle that will be created by completing this quarter circle to a circle. Both those two circles have the same center, that is point A, and they have the same radii, that is R. Two circles with the same center and the same radii, they are not two circles but one circle. Okay, it must be the same circle. And therefore, I can conclude from what I said here that the circle that blocks triangle HGE is the same circle that will be created by completing this quarter circle to a circle. Okay, and for that reason, if you complete this quarter circle to a circle, it must pass through point H. That is one of the vertices of triangle HGE, because it blocks triangle HGE. So the circle that we created by completing this quarter circle to a circle must pass through point H. So we complete this quarter circle to a circle, and it must pass through point H. You see here, this circle passes from point H. Okay, so what is the size of angle HAE? The size of this angle HAE is equals to 90 degrees plus 90 degrees, it is 180 degrees. Any angle that equals to 180 degrees in its size must be a straight line. Therefore, angle HAE is a straight line, or line segment HAE is a straight line. Line segment HAE is a straight line. It is a straight line that touches the circle at 2 points, H and E. Any straight line that touches the circle at 2 points is defined as a chord. Therefore, edge AE is a chord. Okay? But edge AE is a chord that passes from point A, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, edge AE is the diameter of the circle. If edge AE is the diameter of the circle, edge E is also the diameter of the circle. So, according to our conclusion, we found out that edge E is the diameter of the circle. So we know that edge E is the diameter of the circle, and we have here, this is peripheral angle edge GE. Again, this is peripheral angle edge GE. This peripheral angle edge GE is subtended on edge E, that is the diameter of the circle. And you know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. And therefore, this peripheral angle edge GE must be equal to 90 degrees in its size. In the next step, we'll focus on quadrilateral ADGE. We'll focus on this green quadrilateral ADGE. Inside this quadrilateral ADGE, we have those two opposite angles. Each opposite angle equals to 90 degrees in size, and the sum of those two opposite angles, of course, equals to 180 degrees. And you know that any quadrilateral that the sum of its two opposite angles is equal to 180 degrees, it is a cyclic quadrilateral. Therefore, this green quadrilateral is a cyclic quadrilateral. That is to say, we can block this green quadrilateral by a circle. We'll do it now. We'll block this quadrilateral by a circle. Actually, this red circle blocks the green quadrilateral DGEA because it passes for its four vertices that are AG, AD, G, and E. So now we can implement rule 12 in the red circle. I repeat again, we can implement now rule 12 on the red circle. I repeat quickly on rule 12. First of all, rule 12 is true in any circle. In any circle, if we have chord AB and the extended chord AB touches the common extra point P. In addition, we have also chord CD, and the extended chord CD also touches the same common extra point P. So in this moment, the following equation is true: that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule 12 in our drawing. Why? Because in our drawing, if we focus on the red circle, we have in the red circle we have chord GD. This is chord GD, and the extended chord GD touches the common extra point H. In addition, we also have chord EA. This is chord EA, and the extended chord EA also touches the same common external point H. So all the requirements of rule 12 are satisfied, and then therefore we can implement here rule 12. According to rule 12, the following equation will be true, that HD times HG equals to HA times HE. Again, according to rule 12, HD times HG equals to HA times HE. So I write it down. HA times HG equals to, this is actually HD. This is HD times HG. Is HD times HG equals to HA times HE. Repeat again. According to rule 12, HD times HG equals to HA times HE. HD equals to 12 units in its length. What is the length of HG? From drawing it is very easy to see that HG in total equals to HD plus DG. HD is 12, DG is X according to what is given as the equation. So in total HG equals to 12 plus X. Repeat again. HD is 12 times HG is 12 plus X, and it is equals to HA. HA is R times HE. HE is the diameter of the circle, that is equals to 2R, of course. Repeat again. HA is R, HE is 2R. So in conclusion, according to rule 12, we found out that 12 times 12 plus X equals to R times 2R. Here we'll divide this equation 1 by 2. And we get that according to equation 1, in this side of the equation we have 12 over 2, that is 6. So in total this expression, this side of the equation will be equal to 6 times 12 plus X. And it is equal to R times 2R. R times 2R is 2R squared, and 2R squared over 2 is R squared. In conclusion, we found out that 6 times 12 plus X equals to R squared. Here we divide this equation 1 by 6. And we get that according to equation 1, here after we divide this equation by 6, we left only with 12 plus X. This side of the equation, on the other side of the equation, we have R squared over 6. So here we subtract 12 from this equation 1. And finally we get that according to equation 1, X, that is the variable that we are looking for in this question, is equals to R squared over 6 minus 12. According to equation 1, X equals to R squared over 6 minus 12. So in the next step, I will copy this right triangle ADE in a new page. This is the right triangle ADE. This is the right green triangle ADE. So I'll copy it in a new page, and we will implement on this right triangle ADE the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. We have already found out that side AE of the right triangle ADE equals to R. It is the radius of the circle. According to our definition, actually we define one side of square ABCD as y, therefore AD equals to y. Here AD equals to y. AB also equals to y. CB equals to y. And finally DC also equals to y. So actually, this is the right triangle ADE that I copied from the original drawing. We know that DE equals to 12 units in its length, according to what is given as the question. So according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle ADE is DE, therefore the square of the hypotenuse is DE squared, and it must be equal to AD squared plus AE squared. This is equation 2. DE is 12, therefore DE squared is 12 squared, that is 144. And it is equal to AD squared. AD equals to y, it is one side of square ABCD, that is equal to y according to our definition. Therefore AD squared is y squared plus AE squared. AE is r, therefore AE squared is r squared. So actually we found out that according to equation 2, y squared plus r squared equals to 144. In the next step, we'll join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ABC. So we'll copy this right triangle ABC in a new page, and we will implement on this right triangle ABC the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. This will be equation 3. What is the definition of the hypotenuse AC of the right triangle ABC? What is the definition of the hypotenuse AC of the right triangle ABC? The hypotenuse AC starts from point A, that is the center of the circle, and then at point C, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of this circle, that is equal to R according to our definition. So the hypotenuse AC of the right angle BC equals to R. We have already found out that AB equals to Y, and BC also equals to Y. So actually, this is the right triangle ABC that I copied from the original drawing. So this will be equation 3. According to equation 3, in the right triangle ABC, and according to Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is also Y, therefore BC squared is Y squared. So actually we found out that according to equation 3, R squared equals to Y squared plus Y squared, that is 2Y squared. So R squared equals to 2Y squared. We'll divide this equation 3 by 2. And finally we get that according to equation 3, Y squared equals to R squared over 2. This is according to equation 3. I copy again equation 3 in a new page. According to equation 3, Y squared equals to R squared over 2. While according to equation 2, we have already found out that Y squared plus R squared equals to 144. So we have two equations 3 and 2 together here. According to equation 2, y squared plus I squared equals to 144. Now we can substitute y squared in this equation 2, by the value of y squared from equation 3. According to equation 3, y squared equals to r squared over 2. Now we substitute y squared in equation 2 by r squared over 2. We do it now, we get that y squared is r squared over 2 plus r squared equals to 144. Here we multiply r squared by 2 and then we divide it by 2 in order to overcome the factor with r squared over 2. So in total the numerator we will have here r squared plus 2r squared divided by 2. That is equal to 144. R squared plus 2r squared is 3r squared. So in total this expression equals to 3r squared over 2. That is equal to 144. Here we will multiply this equation 2 by 2. And we get that according to equation 2, this side of the equation we left only 3r squared that is equals to 2 times 144 is 288. Here we will divide this equation 2 by 3. And finally we get that according to equation 2, r squared equals to 288 over 3. R squared, according to equation 2, equals to 288 over 3 is 96. So according to equation 2, we actually found out that r squared equals to 96. This is according to equation 2. While according to equation 1, we've already found out that x equals to r squared over 6 minus 12. Now we can substitute r squared in this equation 1, by 96 from equation 2. We'll do it now, and we'll get that according to this equation 1, x equals to r squared is 96. So it is 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. So we actually found out that x equals to 4 units. X is defined as the length of this line segment GD. So the length of line segment GD that is equal to x is equal to 4 units. We finished the first method. Next step, I will present to you how to find out the length of this line segment GD is equal to x according to the second method. So first of all, we know that ABCD is a square. All the 4 angles inside square ABCD are right angles. So this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. This angle equals to 90 degrees in its size. And finally, this angle is also equals to 90 degrees in its size. In addition, we know that in any square, the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. So I write it down. In square ABCD, side DC is parallel to the opposite side AB. But AB is part of the straight line AE. Again, AB is part of the straight line AE. So part of the straight line AB is parallel to DC, therefore the straight line itself must be also parallel to DC. That is to say, AE must be also parallel to DC. We know that AE is parallel to DC. Those two angles, they are defined as alternating angles, and they are located between the parallel lines DC and AE. Here DC is parallel to AB. And therefore, they are equal to each other. They are equal to each other according to the rule that alternating angles between parallel lines are equal to each other. But this angle equals to theta according to what is given as the equation. Therefore, this angle must be also equal to theta because they are equal to each other. Okay. In the next step, we'll do a construction. That is to say, from point G, we will draw perpendicular on AB. Again, from point G, we will draw perpendicular on AB. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We'll define the touching point of the perpendicular from point G and AB is point N. Likewise, we define the intersection point of the perpendicular GN with side DC of the square as M. So by doing this construction, we created this quadrilateral DM and A. We have this quadrilateral DM and A. Inside, again, I will write down here also, this angle also equals to 90 degrees. Okay, because it is one out of 4 angles of square ABCD. Therefore, it must be equal to 90 degrees in its size. So, which angles we have inside quadrilateral AMDAN? We have 1, 2, 3 right angles. And therefore, the fourth angle must be also equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral we have 4 right angles, any quadrilateral, inside quadrilateral DMAN we have 4 right angles, and we know that any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral DMAN with 4 right angles as a rectangle. So right here, quadrilateral DMAN is a rectangle because it has 4 right angles. Likewise, in this quadrilateral MCNB, we also have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees. And therefore, this quadrilateral is also a rectangle because it has 4 right angles. GN is perpendicular. So GN is a perpendicular, it is absolutely a straight line. If you focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Repeat again. In order to complete the sum of the angles on the left side of GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. And therefore, the small triangle DGM is a right triangle. So copy the right triangle DGM in a new page, and we will analyze this right triangle DGM. The hypotenuse GM equals to x, according to what is given as the question. X is the variable that we are looking for. this question. So actually, this is the right triangle DGM that I copied from the original drawing. It is very easy to see that this triangle DGM cosine theta equals to dm over dg. Cosine theta equals to dm over dg. So cosine theta equals to dm. Dm is the missing variable, so we leave it as it is, over dg. dg is x. In conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally we get that according to equation 1, dm equals to x times cosine theta. In the next step, I'll copy this right triangle ADE in a new page, and we will analyze this right triangle ADE. But first of all, we will define one side of this square ABCD as y. Therefore, all the four sides of square ABCD will be equal to y. That is to say, AD equals to y, side AB equals to y, side CB equals to y, and finally side DC, this is side DC, it is also equals to y. So I'll copy the right triangle ADE in a new page. This is angle theta. What is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and then at point E, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AE is the radius of the quarter circle. We will define the radius of the quarter circle as R, and therefore AE equals to R. That is to say, side AE of triangle ADE equals to R. And side AE equals to R, this is the radius of the quarter circle, and side AD equals to y, according to our definition, it is one side of square ABCD. AD equals to y. And DE equals to 12 units in its length, according to what is given as the question. So actually, this is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see from the drawing that cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So in total, cosine theta equals to R over 12. Cosine theta equals to R over 12. This is according to equation 2. While according to equation 1, we have already found out that dm equals to x times cosine theta Now we substitute cosine theta in this equation 1 by r over 12 from equation 2. We'll do it now and we get that dm equals to x and cosine theta is r over 12. So in total we actually found out that cosine theta according to equation 1, that dm according to equation 1 equals to xr over 12. Here, this is side dm, and it is equal to xr over 12. But we have already found out that quadrilateral DMAN is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle DMAN, side DM equals to side AN. But DM equals to XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule in the same rectangle DMAN, side DA must be equal to the opposite side MN. But DA equals to Y, therefore MN must be also equal to Y. We'll continue to analyze the right triangle DGM. So I copy the right triangle DGM again in Olympiad and we'll continue to analyze it. So actually, this is the right triangle DGM that I copied from the original drawing. From the drawing, it is very easy to see that in the right triangle DGM, sinus theta equals to GM over DG. So sinus theta equals to GM, GM is the missing side, therefore we leave it as it is, over dg, dg is x. So in conclusion, according to equation 1, we actually found out that sinus theta equals to gm over x. We multiply this equation 1 by x. And finally we get that according to equation 1, gm equals to x times sinus theta. In the next step, I will copy the right triangle AD again in this new page and we continue to analyze it. The hypotenuse D equals to 12 units in its length, according to what is given as the question. Side AD equals to y, and finally side A of the right triangle AD equals to r. It is the radius of the quarter circle. It is equal to r according to our definition. So actually, this is the right triangle ADE that I copied from the original drawing. The most important thing is that this angle is angle theta. In this right triangle ADE, it's very easy to see that sinus theta equals to AD over DE. So sinus theta equals to AD, that is y, over DE, that is 12. So in conclusion, according to equation 2, we actually found out that sinus theta equals to y over 12. This is according to equation 2. And according to equation 1, we have already found out that Gm equals to x times sinus theta. Now we can substitute sinus theta in this equation 1, by y over 12 from equation 2. We do it now, and we get that Gm will be equal to x, and sinus theta is y over 12. So in conclusion, we should have found out that Gm equals to x times y over 12. This is side GM or line segment GM, and it is equal to x times y over 12. Okay. In the next step, we will join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle that is equal to r according to our definition. So copy this right triangle AGN in a new page, and we will implement on this right triangle AGN the Pythagoras theorem. Here, by PT is the abbreviation for Pythagoras theorem. The hypotenuse AG equals to r, according to what we just right now found out. It's the radius of the circle or the quarter circle. We have already found out that side AN equals to XR over 12. What is the length of this line segment? Line segment GN. It's very easy to see from the drawing that GN in total equals to GM plus MN. GM is XY over 12, MN is Y, therefore in total Gn equals to xy over 12 plus y. So I write it down. Here, Gn in total equals to xy over 12 plus y. So this is the right angle AGN that I copied from the original drawing. Now we'll implement on this right angle triangle AGN the Pythagoras theorem. This will be equation 1. According to the Pythagoras theorem, in this right triangle triangle AGN, AG squared equals to AN squared plus GN squared. AG is R, therefore AG squared is R squared, and it is equal to AN squared. AN is XR over 12, therefore AN squared is XR over 12 squared, that is actually equals to X squared times R squared over 12 squared, that is 144, plus GN squared. GN is XY over 12 plus Y, therefore GN squared is xy over 12 plus y squared. So here we take a common factor of y from this expression, and we will get that according to equation 1, we have here r squared, that is equals to x squared times r squared over 144. If it again, we'll take from this equation y is the common factor. So y is taken as a common factor on this expression. So what is left from xy over 12 after we took from it y as a common factor? What is left is actually x over 12 plus what is left from y after we took from it y as a common factor. What is left is actually 1. So actually found out that according to equation 1, r squared equals to x squared times r squared over 144 plus y times x over 12 plus 1 over plus 1 squared. So we'll open one pair of brackets of this expression, and we get that according to this equation, equation 1, r squared equals to x squared times r squared over 144 plus, here we'll open one pair of brackets here, and we get that here we have y squared, and here we have x over 12 plus 1 also squared. So here we will multiply 1 by 12, and then we will divide it by 12 in order to common factor with x over 12. And we get that according to this equation, equation 1, r squared equals to x squared times r squared over 144 plus y squared. So here we multiply 1 by 12, and then we divide it by 12. So the numerator in total we will have x plus 12 divided by 12 squared. And we have here the algebraic identity that states that a over b squared equals to a squared over b squared. according to this algebraic identity, we get that x plus 12 over 12 square will be equal to x plus 12 square over 12 square, that is 144. And we have to multiply it by y squared plus x squared times r squared over 144 equals to r squared according to this equation, equation 1. So, in the next step, we will join points A and C together by a straight line. By joining points A and C, we created the right triangle, triangle ABC. So copy the right triangle ABC in the new page, and we will implement the Pythagoras theorem on the right triangle, triangle ABC. Here by PT is the relation for Pythagoras theorem. What is the definition of the hypotenuse AC of the right triangle ABC? Actually, the hypotenuse AC starts from point A, that is the center of the quarter circle, and that's at point C, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the quarter circle that is equal to R according to our definition. AC equals to R. So the hypotenuse AC equals to R. It is also the radius of the quarter circle. We have, according to our definition, AB equals to Y, and BC also equals to Y. So actually, this is the right triangle, triangle ABC that I copied from the original drawing. This triangle, triangle ABC, according to the Pythagoras theorem, we get that AC squared equals to AB squared plus BC squared. AC equals to R, therefore AC squared is R squared, and it equals to AB squared. AB is Y, therefore AB squared is Y squared plus BC squared. BC is also Y, therefore BC squared is Y squared. So in conclusion, we actually found out that according to equation 2, R squared equals to Y squared plus Y squared, that is 2Y squared. Repeat again. According to equation 2, we actually found out that R squared equals to 2Y squared. Here we divide this equation 2 by 2. And we get that according to equation 2, Y squared equals to R squared over 2. This is according to equation 2. While according to equation 1, we have already found out that R squared equals to x squared times R squared over 144 plus y squared times x plus 12 squared divided by 144. So we have here two equations, equation 1 and equation 2. Here we divided this equation 2 by 2, and according to equation 2, actually found out that y squared equals to r squared over 2. This is according to equation 2. Actually, y squared equals to r squared over 2. We don't have to divide equation 2 by 2, because we have equation 2 that states that r squared equals to 2y squared. This is according to equation 2. We have here equation 1. The only thing that we have to do here is to substitute r squared in equation 1 by 2y squared from equation 2. We'll do it now, and we get that according to equation 1, we have here r squared, and r squared according to this equation 2 is 2y squared. So we substitute r squared in this equation 1 by 2y squared, and it is equals to x squared, and r squared is 2y squared, divided by 144 plus y squared times x plus 12 squared divided by 144. Here we divide this equation 1 by y squared, and we get that according to equation 1, 2y squared over y squared is 2, and it is equals to, here y squared will get cancelled because we divided the equation by y squared, and we left only with 2x squared over 144. Here y squared will also get cancelled, and we left only with x plus 12 squared divided by 144. Here we multiply this equation 1 by 144, and we get that according to this equation 1, 2 times 144 is 288, and it is equals to 2x squared plus x plus 12 squared. Here we'll open the brackets of this expression, and we get that according to equation 1, 288 equals to 2x squared, and x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So here, according to equation 1, we actually found out that 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we substitute we subtract 288 from this equation 1, and we get that according to equation 1, here we have 3x squared plus 24x, and here we have 144 minus 288 equals to minus 144, that is equal to 0. Here we divide this equation by 3, and we get that according to equation 1, 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48, that is equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1. The coefficient b equals to 8, and finally the coefficient c equals to minus 48. Now we have to put the values of a, b, and c for this specific quadratic equation inside the general equation for x, this general equation for x, in order to find out the value or the values of x for this specific quadratic equation. I will remind you that x for our specific quadratic equation is defined as the length of this line segment GD. We'll do it now. We'll put the values of a, b, and c from our specific quadratic equation inside this general formula in order to find out the value of x for our specific quadratic equation. Okay, again that we'll do it now, and we get that here x equals to minus b. b is minus 8, therefore minus b is 8, therefore b is minus 8. Again, b is 8, therefore minus b is minus 8, plus minus the square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 48, and minus 4 times minus 48 is plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So actually found out that x equals to minus 8 plus minus. Inside the root we have 64 plus 192 is 256 divided by 2. So here x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution, x equals to minus 12. But x can never be equal to minus 12 because of the fact that x is the length of this line segment DG, and x as a length must be a positive number. It can never be equal to a negative number. So this solution is incorrect solution. We cancel this solution, and we have to take out only a positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So x equals to 4 units. Repeat again that x is the length of this line segment GD. So line segment GD that is equal to x is equals to 4 units in its length. That is the answer for question according to the second method. The next step, I will summarize the lecture. We start with the first method, of course. Repeat again the question. In this question, our mission is to find out the length of this line segment GD that is equal to x. We have to find out the value of x. So in the domain we have a quarter circle. FAE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, you know that this is line segment DE that is equal to 12 units in its length. This is angle GDE that is equal to theta. And this is angle CDE that is also equal to theta. I repeat again that our mission is to find out the length of this line segment GD that is equal to x. So in the first method, first of all, we know that ABCD is a square, and we know that all the angles inside a square are right angles, so all those 4 angles, they are all right angles. Okay, so here we have angle CDA is a right angle. It is equal to 90 degrees in its size, and this is angle theta. So the missing angle, angle ADE, this missing angle must be equal to the big angle FDA minus this angle theta. The big angle CDA, that is a right angle, minus this angle theta. So the missing angle ADE equals to 90 degrees minus theta. Okay, so in the next step we did a construction. That is to say, we extended side GD or line segment GD in line segment EA by side line until they touch each other. This is their touching point, and we define their touching point as edge. In the next step, we actually extended side CD of square ABCD by straight line. By extending side CD, we added those 2 vertex angles that are equal to each other. But this vertex angle equals to theta, therefore this angle must be also equal to theta because those 2 angles are equal to each other. CD is one side of square ABCD, therefore it is absolutely a straight line. We extended the straight line CD by straight line, and the result is CF, that is, must be also a straight line. So if you focus on the lower side of the straight line CF here at point D, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CF at point D? We have this angle that is a right angle plus this missing angle. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore this missing angle must be equal to 90 degrees in its size. Okay, so the big angle FDA equals to 90 degrees. This angle equals to theta. Therefore this missing angle, that is to say angle edge edge DA must be equal to 90 degrees minus theta. Here we extended side EA by side line, and the result is a edge. When you extend the straight line by straight line, the result must be a straight line, so E edge is a straight line. So if we focus on the upper side of the straight line E edge at point A, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have the upper side of the edge at point A? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we proved that those two right angles can go into each other. That is to say, we proved that this right angle ADH is congruent to this right angle triangle ADE. So why those two right angles can go into each other? First of all, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side DA. Side DA is a common side that belongs to both triangles. So we can write down that side DA equals to itself as a common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually proved that the right triangle ADH is congruent to the right triangle ADE according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that the two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between the two angles in a second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. We actually proved that those two angles and the side that included between those two angles, that is actually side DA in the right triangle ADE are correspondingly equal to those two angles, and the side that is included between those two angles, that is the same side, side DA, in the right triangle ADH. Therefore, we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. Repeat again, we derive that DE equals to DH. But according to what is given as the equation, DE equals to 12. So I can write here that DE equals to 12, and from this equation 12 equals to DE equals to DH, we derive that DH is also equals to 12 units in its length. Here, this is side DH, this equals to 12 units in its length. Likewise, according to the sum rule that corresponding sides and congruent triangles are equal to each other, we derive that side AE in the right triangle ADE is equal to side AH in the right triangle ADH. But what is the definition of AE? AE is the radius of this quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. Here, according to our definition, AE equals to R. And from this equation, R equals to AE equals to AH, we will derive that AH also equals to R. If AH is also equals to R, that is to say it is also the radius of the circle that will be created by completing the quarter circle to a circle. Okay, in the next step, we join points G and E together by a straight line. By joining points G and E, we created the triangle edge GE. This is triangle edge GE that we created by joining points G and E. In the next step, we join points G and A together by a straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that's equal to R according to our definition. AG equals to R. Actually, point A in relation to triangle HGE is defined as the circumcenter of triangle HGE. Again, point A is the circumcenter of this triangle HGE. That is to say, the distance of this point A from the three vertices of triangle HGE, the distance is equal. The three vertices of triangle HGE are H, G, and E. For example, the distance of point A from the vertex H is R. Likewise, the distance of point A from the vertex E is also r because A equals to r, and finally the distance of point A from the vertex G of triangle AGE is also r because AG equals to r. Therefore, point A is defined as the circumcenter of this triangle HGE. In addition, point A is also the center of the circle that blocks triangle HGE. Again, this is point A is the center of the circle that blocks triangle HGE. We know that any circle that blocks triangle HGE must pass through its three vertices that are H, G, and E. And especially it must pass from point E, that is the vertex of triangle HGE. So what is the radius of the circle that blocks triangle HGE? The radius of any circle must start from the center of the circle, that's actually point A, and it ends at point E, that is a point on the circle itself. And definitely point E is a point on the circle that blocks triangle HGE, because any circle that blocks triangle HGE must pass for its three vertices, and point E is one vertex of triangle HGE. Therefore, the circle that blocks triangle HGE must pass for point E. So point A is the center of the circle that blocks triangle HGE, and point E is a point on the circle that blocks triangle HGE. This is exactly the definition of a radius. Therefore, AE is the radius of the circle that blocks triangle HGE. And we already found out that A equals to R. In conclusion, you can summarize and say that the circle that blocks triangle HGE, the center of the circle that blocks triangle HGE is here at point A. Its radius is R, and it must pass through the three vertices of triangle HGE that are H, G, and E. This is from one side, but from the other side, if we complete this quarter circle to a circle, we will get a circle that its center is here at point A, and its radius must be also equal to R because of the fact that the radius of the quarter circle is R. Therefore, the radius of the circle that will be created by completing the quarter circle to a circle must be also equal to R. So we have here two circles with the same radii, that is R, and the same center, that is A. Two circles with the same radii and the same circles, the same radii and the same center, they are not two circles but one circle. It is the same circle. That is to say, the circle that blocks triangle HGE is the same circle that will be created by completing the quarter circle to a circle. Therefore, the circle that will be created by completing this quarter circle to a circle must pass through point H because it blocks triangle HGE. Because the circle that will be created by completing this quarter circle to a circle, it is the same circle that blocks triangle HGE. Therefore, it must pass through point H. Okay. So, what is the size of angle HAE? The size of angle HAE equals to 180 degrees. It is 90 degrees plus 90 degrees. That is 180 degrees. And any angle that's equal to 180 degrees in its size is defined as a straight line. So HAE is a straight line. But HAE is a straight line that touches the circle at 2 points, H and E. And any straight line that touches the circle at 2 points is defined as a chord. Therefore, HAE is a chord, but HAE is a chord that passes through point A, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord HAE is the diameter of this circle. If HAE is the diameter of the circle, then HE is also the diameter of the circle. Here, HE is the diameter of the circle. So, this is peripheral angle HGE. This angle is defined as peripheral angle HGE. and this peripheral edge GE is subtended on edge E, that is the diameter of the circle. And we know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral edge GE must be equal to 90 degrees in its size. In the next step, we focus on the green quadrilateral ADGE. In this quadrilateral ADGE, we have two right angles. The sum of two right angles is 180 degrees, and we know that any quadrilateral that the sum of its two right angles is equal to 180 degrees in its size is a cyclic quadrilateral. That is to say, we can block this quadrilateral ADGE by a circle. So actually, I block this quadrilateral, this green quadrilateral, by this red circle. This circle blocks the quadrilateral ADGE because of the fact that it passes through its four vertices that are A, D, G, and E. Now we can implement rule 12 in the red circle. We repeat quickly on rule 12. According to rule 12 is true in any circle. So this circle could be any circle. We have here inside the circle a chord AB. The extended chord AB touches point P, and we have in addition the extended chord CD also touches the same common extent point P. So in this domain, the following equation is true: that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement all 12 in our drawing in the red circle. Why? Because in the red circle we have chord GD. This is chord GD, and the extended chord GD touches the common extent point H. In addition, we also have this is chord EA, and the extended chord EA touches the same common extent point H. So all the requirements for rule 12 are satisfied, and therefore we can implement rule 12. According to rule 12, the following equation is true: that edge D times edge G equals to edge A times edge E. Again, edge D times edge G equals to edge A times edge E. And again, according to rule 12, the following equation is true: that edge D times edge G equals to edge A times edge E. Edge D is 12. Edge G in total equals to edge D plus GD. Edge D is 12 and DG is X. In total, edge G equals to 12 plus X. Repeat again, edge D is 12 and edge G is 12 plus X, and this is equal to edge A. Here edge A is R, and edge E is the diameter of the circle, that's equal to 2R. Repeat again, edge A is R and edge E is 2R. Here we divided this equation 1 by 2, and finally found out that 12 over 2 is 6. So in total this expression equals to 6 times 12 plus X, and this is equal to, here we have 2R times 2R is 2R squared, and 2R squared over 2 is R squared. So in conclusion, according to equation 1, we found out that 6 times 12 plus X equals to R squared. Here we divided this equation 1 by 6, and finally found out that in this side of the equation we left only with 12 plus X. On the other side of the equation we will have R squared over 6. Here we substituted from this equation 1, 12. Finally, according to equation 1, we actually found out that X is the variable that we are looking for in this question, is equal to R squared over 6 times 12. In the next step, I copied this right triangle ADE in a new page, and we implemented the Pythagoras theorem on this right triangle ADE. But before that, we defined one side of square ABCD as Y. Therefore, all the four sides of square ABCD must be equal to Y. AD equals to Y, AB equals to Y, BC equals to Y, and DC equals to Y. And we already found out that side AE on the right triangle AD equals to R. and the hypotenuse D equals to 12 units in itself according to what is given as the question. So this is the right triangle ADE. In this right triangle ADE, according to the Pythagoras theorem, DE square equals to AD square plus AE square. DE is 12, therefore DE square is 12 squared, that is 144, and it is equals to AD square. AD is y, therefore AD square is y square plus AE square. AE is r, therefore AE square is r square. So according to equation 2, we found out that 144 equals to y square plus r square. In the next step, we join points A and C together by straight line. By joining points A and C, we created the right triangle, triangle ABC. So I copied this right triangle ABC in a new page and we implemented the Pythagoras theorem in this right triangle, triangle ABC. This is the right triangle, triangle ABC that I copied from the original drawing. What is the definition of the hypotenuse AC? The hypotenuse AC starts from point A, that is the center of the circle, and then at point C, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, AC is also the radius of the circle, that is equal to 1. We have already found out that AB equals to Y and BC equals to Y. Both those two sides are the sides of the square, and one side of square ABCD equals to y. So according to the Pythagoras theorem in this right triangle ABC, AC square equals to AB square plus BC square. Again, AC square equals to AB square plus BC square. AC is r, therefore AC square is r square, and it is equals to AB square. AB square. So AB is y, therefore b square is y square, plus bc square. Bc is also y, therefore bc square is y square. So in conclusion, actually, according to this equation, equation 3, we found out that r square equals to y square plus y square, that is 2y square. Here, we divided this equation, equation 3, by 2, and finally found out that y square equals to r square over 2. Repeat again, according to equation 3, we actually found out that y square equals to r square over 2. This is according to equation 3, while according to equation 2, we have already found out that y square plus r square equals to 144. So now we can substitute y square in this equation, equation 2, by r square over 2 from equation 3. We did it and found out that according to equation 2, y square is r square over 2 plus r square equals to 144. Here we multiplied r square by 2 and then we divided by 2 in order to a common factor with r square over 2. So in total, the numerator of this expression we have r square plus 2r square divided by 2 is equal to 144. Here we multiply this equation 2 by 2. In this side of the equation, we left with r square plus 2r square is 3r square. Again, we have here r square plus r square is 3r square, so in total this expression equals to 3r square over 2, that is equal to 144. Here we multiply this equation 2 by 2, and finally found out in this side of the equation we left with 3r square, and the other side of the equation we have 144 times 2, that is 288. Here we divided this equation 2 by 3, and finally found out that r square equals to 288 over 3. This is according to equation 2, r square equals to 288 over 3, that is 96. So r square equals to 96 according to equation 2, while according to equation 1, we have already found out that x equals to r square over 6 minus 12, and r square is 96, so we can substitute r square in this equation 1 by 96 from equation 2. We did it and found out actually that x equals to r square is 96, so in total this expression equals to 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 3. So actually found out that x equals to 4 units in its length. I repeat again, the length of this line segment GD is equal to x is equals to 4 units. We finished with the first method. The next step I actually presented to you how to find out the length of this line segment GD is equal to x according to what is given in the question in the second method. So first of all, we know that square ABCD inside any square, all the four angles are right angles, so those four angles inside square ABCD are right angles. And we also know that in any square, the opposite sides of any square are parallel to each other. So in this square ABCD, side DC is parallel to the opposite side AB. Again, here, side DC is parallel to the opposite side AB in square ABCD. But AB is part of the straight line AE. Again, AB is part of the straight line AE and is parallel to DC. If part of the straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. So therefore therefore AE, the straight line itself AE, must be also parallel to DC. We found out that AE is parallel to DC, and those two angles, they are defined as alternating angles, and you know that alternating angles that are located between parallel lines are equal to each other. Those two alternating angles, they are located between the parallel lines DC and AE. Again, DC is parallel to AE, and therefore they are equal to each other. So those two alternating angles, they are equal to each other. But this angle equals to theta, therefore this angle must be also equal to theta, because those two angles are equal to each other. These alternating angles that are located between the parallel lines DC and AE. Therefore this angle must be also equal to theta. The next step, we did a construction, that is to say, from point G we draw perpendicular on AB. Again, from point G we draw perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point G and AB as N. Likewise, we defined the intersection point between perpendicular GN and side DC of the square as M. By doing this construction, we created quadrilateral DM and A. Inside quadrilateral DM and A, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees in size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral DMAN we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we do that to quadrilateral DMAN as a rectangle. Likewise, inside this quadrilateral MC and B we have 1, 2, 3 right angles. Therefore the fourth angle must be equal to 90 degrees. Therefore quadrilateral MCNB with 4 right angles is a rectangle. And note that GN is perpendicular. GN is a perpendicular. It is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle is equal to 90 degrees in its size, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Therefore, the small triangle GMD is a right angle. So I copy this right angle GMD in the new page, and we analyze this right angle, triangle GMD. This is the right triangle GMD that I copied from the original drawing. It is given as the question that the hypotenuse GD of the right triangle GMD is equal to x. We have to find out the length of the hypotenuse GD that is equal to x. We have to find out the value of x in this question. In addition, we know that this is angle theta, and this angle equals to 90 degrees, according to what we have already found out. So in the right triangle GMD, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. dm is the missing side, so we leave it as it is. So it is dm over dg. dg is x. So in total, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. Okay, here, dm equals to x times cosine theta. This is according to equation 1. In the next step, I copied this right triangle ADE in this new page and analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. Side AE is the radius of this quarter circle. We define the radius of this quarter circle as r, therefore AE equals to r according to our definition. One side of square ABCD, we define one side of square ABCD as y, therefore all the four sides are equal to y. And especially side AD of square ABCD equals to y. And it is given as the question that the hypotenuse DE of the right triangle AD equals to 12 units in its length. So DE equals to 12. Here we implemented, actually, in this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. Cosine theta equals to AE, that is R, over DE, that is 12. So in total, cosine theta equals to R over 12. Here, according to equation 2, cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. Now we can substitute cosine theta in this equation 1 by r over 12 over equation 2. We did it and we found out that actually the dm equals to x times cosine theta, and cosine theta is r over 12, so in total dm equals to xr over 12. Here, dm, this is side dm, that is equal to xr over 12. We have already found out that dman is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. So in rectangle dman, side dm must be equal to the opposite side an, but dm is xr over 12, therefore an must be also equal to xr over 12. Likewise, according to the sum rule in the same rectangle dman, side AD must be equal to the opposite side NM, but AD equals to y, therefore NM must be also equal to y because those two sides are equal to each other. Then we return back to the right triangle DGM. We continue to analyze the right triangle DGM. This is the right triangle DGM that I copied from the original drawing. This right triangle DGM, it is very easy to see that sinus theta equals to GM over DG. Again, sinus theta equals to GM over DG. GM is the missing side, so we leave it as it is. So it is GM over DG. DG is x, so we substitute DG by x. So in conclusion, I should have found out that sinus theta equals to gm over x. Here we multiplied this equation 1 by x, and finally found out that gm equals to x times sinus theta. The therefore this side gm is x times sinus theta. Then I copied again the right triangle ADE in this new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. We have already found out that A equals to r, this is the radius of the circle. AD equals to y according to our definition. So, and this is angle theta according to what we have already found out. In the right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Again, sinus theta equals to AD over DE. AD is y and DE is 12. So in total, sinus theta equals to y over 12. According to equation 2, sinus theta equals to y over 12, while according to equation 1, we have already found out that gm equals to x times sinus theta. Now we can substitute sinus theta in this equation 1, by y over 12 from equation 2. We did it and found out actually that gm equals to x times sinus theta, and sinus theta is y over 12, therefore gm in total equals to xy over 12. Here, this line segment GM or side CM equals to XY over 12. And we have already found out that MN equals to Y. In the next step, we join points A and G together by straight line. What is the definition of line segment AG? Line segment AG starts from the center of the quarter circle, that is point A, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle, that is equal to R according to our definition. Here, AG equals to R. Then I copied this right triangle AGN in a new page and we implemented the Pythagoras theorem on this right triangle AGN. This is the right triangle AGN that I copied from the original drawing. We just right now found out that the hypotenuse AG of the right triangle AGN equals to R. It is the radius of the circle also. We have already found out that AN equals to XR over 12. And the side GN of this right triangle AGN in total equals to GM plus MN. Again, GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. Repeat again. Side GN of the right triangle AGN in total equals to XY over 12 plus Y. So in the right triangle AGN, according to the Pythagoras theorem, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 squared, that is actually X squared times R squared over 12 squared, that is 144. So in total XR over 12 equals to X squared times R squared over 144 plus GN squared. GN is XY over 12 plus Y, therefore GN squared is XY over 12 plus Y squared. So here we took Y as a common factor from this expression. So what is left from this expression XY over 12 after we took from it Y as a common factor? What is left is actually X over 12. And what is left from this expression from Y after we took it from it Y as a common factor? What is left is actually 1. So in total, after we took Y as a common factor, inside the brackets we have X over 12 plus 1, and Y is a common factor, all squared. And we have also in the question 1, X squared times R squared over 144, that is equal to R squared. Here we opened one pair of brackets on this expression, and found out actually, after we open the brackets, one pair of brackets, we will have here Y squared, and here also X over 12 plus 1 squared, that is equal to X squared plus R squared over 144, that is equal to R squared. Here we multiplied 1 by 12 and then divided by 12 in order to have a common factor with X over 12. So in total, in the numerator we have X plus 12, because we multiplied 1 by 12, divided by 12. And we have to multiply it by Y squared plus X squared over R squared, X squared times R squared over 144, that is equal to R squared. Here we have the algebraic identity that A over B squared equals to A squared over B squared. According to this algebraic identity, X plus 12 over 12 squared will be equal to X plus 12 squared over 12 squared, that is 144. Repeat again. According to this algebraic identity, this expression will be equal to X plus 12 squared over 12 squared, that is 144. And we have to multiply this expression by Y squared and plus X squared times R squared over 144, that is equal to R squared. In the next step, we join points A and C together by straight line. By joining points A and C, we created the right triangle ABC. So copied this right triangle ABC in a new page, and we implemented the Pythagoras theorem on this right triangle ABC. What is the definition of the hypotenuse AC of the right triangle ABC? The hypotenuse AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the quarter circle, that is equal to R according to our definition. Here, therefore, AC equals to R. According to our definition, AB and BC are both the sides of square ABCD, therefore they are both equal to Y. In this right triangle ABC, according to the Pythagoras theorem, AC square will be equal to AB square plus BC square. Again, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square. And it is equal to AB square. AB is Y, therefore AB square is Y square plus BC square. BC is Y, therefore BC square is Y square. So, in conclusion, actually found out that R square equals to Y square plus Y square, that is 2Y square. Repeat again. According to equation 2, we actually found out that R square equals to 2Y square. This is according to equation 2. While according to equation 1, we've already found out that R square equals to X square times R square over 144 plus Y square times X plus 12 square over 144. Now we can substitute R square, in this equation 1, by 2Y square from equation 2. We did it and found out here that according to equation 1, R square is 2Y square, and it is equal to X square, and R square is 2Y square over 144 plus Y square times X plus 12 square over 144. Here we divided this equation 1 by Y square, and finally found out that 2Y square over Y square is 2. Here Y square will get cancelled, and we left only with 2x square over 144. Here Y square also will get cancelled, and we left only with x plus 12 square over 144. Here we multiply this equation 1 by 144, and according to equation 1, we actually found out that 2 times 144 is 288. Here 144 will get cancelled because we multiplied the equation by 144, and we left only with 2x squared. Here 144 in the denominator will also get cancelled, and we left only with x plus 12 squared. So in conclusion, according to equation 2, we actually found out that 288 equals to 2x squared plus x plus 12 squared. Here we open the brackets of this expression and finally found out that according to equation 1, 288 equals to 2x squared plus x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So in conclusion, according to equation 1, we found out that 288 equals to 2x squared plus x squared, that is 3x squared, plus 24x plus 144. So in conclusion, according to equation 1, we found out that 288 equals to 3x squared plus 24x plus 144. Here we subtracted 144, we subtracted 288 from this equation 1, and finally found out that in this side of the equation we have 3x squared plus 24x, and 144 minus 288 equals to minus 144. So according to equation 1, we found out that 3x squared plus 24x minus 144 equals to 0. Here we divided this quadratic equation by 3, and finally found out that 3x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48 is equals to 0. Repeat again. X squared plus 8x minus 48 equals to 0. This is the quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. Now we have to put the values of A, B, and C that we found for our specific quadratic equation in this general formula for x in order to find out the value of the values of x for our specific quadratic equation. I will remind you that x in our specific quadratic equation is defined as the length of this line 7DG. The length of line 7GD equals to x, and this is the variable that we are looking for in this question. So we put the values of A, B, and C for our specific quadratic equation in this general formula for x and found out the value of x. So according to this general formula, x will be equal to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, so minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So x equals to minus 8 plus minus 64 plus 192 is 256 divided by 2. So x equals to minus 8 plus minus, the square root of 256 is 16 divided by 2. So x equals to minus 8 plus minus 16 over 2. Here we have two solutions that are possible for x. The first solution for the value of x is x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12. But if because of the fact that as x is the length of this line 7GD, so x as a length must be a positive number. So the negative solution for x is incorrect solution. X as a length can never be a negative number, so the negative solution is incorrect solution. So we focus on the positive solution for x, and the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So finally found out that the length of this line 7GD that is equal to x is equals to 4 units. Repeat again, x equals to 4 units in its length. Okay, thank you very much.